Hey guys, we recently crossed the 2000 subscribers mark and I thought to do something special. So in this video, we're gonna decode a very beautiful poem dedicated to the Python programming language. It's called The Zen of Python by Tim Peters, which was published in 2004. So what is Zen of Python? It is actually a collection of 20 software principles which guide the design of the Python programming language. And you can always check out this poem by doing a very simple import. You can simply do import this and you will get the complete poem in front of you. So now without wasting any time, let's enjoy and decode this beautiful poem.
Beautiful is better than ugly.
Well, who doesn't like beautiful code? Python, being precise, concise, explicit, and elegant at the same time, provides you the syntax which is easier to read, write, and understand.
Explicit is better than implicit.
Your code should never create confusion in the mind of the person who is trying to read it. For example, every time you call a function, you should be naming the module explicitly. For example, if you want to use the sine function of the math module and you do it something like this, and then in your code, at some stage you define a function called sine, or let's call it sin, and in which you are just doing printing something like not commenting your code is a sin, and afterwards if you just try to call sin, it's gonna give you a different result. It's not gonna give you the sign value of anything, right? So this might create a confusion in the mind of the person who's trying to read your code. A better way to deal with this is to import the module itself and then just call that function by naming its module like this. So this is a better way of dealing with this. Another example is the case of some languages which try to go a bit implicit. For example, JavaScript. In JavaScript, it's allowed to add a string with a number, and what you get in result is actually a concatenation of your string with the string representation of that number. But this is quite implicit and a lot of things are happening behind the scenes, and Python will never allow that. If you just try to do this abc plus 3, it gives you a type error and it's perfectly normal. And a better way to do it is to do it explicitly by over by typecasting your integer with the string function. So this is how you do it, and all you need to do is that you need to be specific and concrete about whatever you are writing in your code.
Simple is better than complex.
A simple solution is always better than a complex one. Let me give an example. Let's consider that you have got a list, let's say 1, 2, 3, 4, 5, and you've got the task of reversing it. And in order to reverse it, what you do is you create a new empty list in which you put a loop over your original list and you keep on inserting the elements from the end of your original list to this new list, and finally you get the result something like this. And how complex is that? A better way of doing this is to simply use the indexing techniques of the Python lists, something like this, and you will get the same result. So what we learn from this is that as a programmer, one should always try to simplify the complex solutions.
Complex is better than complicated.
So now complex is like doing a thing which is hard to understand, whereas complicated is like overdoing the things. So let's say you have to just print the first five whole numbers, and for doing that what you do is you create a new variable counter and you just put a while loop for which while counter is less than 5, you just keep on printing the value of counter while you keep on increasing its value in each iteration. So you get something like this, right? But it is like overdoing the things. Like for a person who is a noob and doesn't know about the for loop, and if you just try to teach them that there is a function called range which simply takes the start, stop and step value which have some default values, and if you just put 5, it will keep the start as 0 and go up to 4 and will print those values, then it may be a bit complex for that person, but it is not at all complicated, and you get the result. So the thing is same, but there is always you can, if you can just do it in a bit complex way rather than making it complicated, that is much better.
Flat is better than nested.
So a flat syntax is typically easier and faster to parse and should be preferred. So let me give an example. Consider that you got two variables and you have a particular condition in which you have to check if a is 1 and b is 2 or not. So this is a way of doing this, but this is a nested way, whereas this one is a flat way. And whenever it is really necessary to use a nested syntax, then one should prefer to keep it shallow, as much shallow as possible, and not make it deeply nested. So that should be the preferred way.
Sparse is better than dense.
Even though the Python syntax allows you to do a thing in a very compact way, but if it is affecting the readability of your code, then it is better to avoid it. For example, consider that you've got a variable a, and if you're just checking, like, if a is greater than 0, then you will print this. If it is actually 0, then you will do this, otherwise you will do this. So it's allowed to write if else conditions like this in a single line, like what you need to do. If that condition is true, then you can just write that in a single line if it is actually only a one line block. So you can do it something like this, but it is affecting the readability of my code, and it is better if I go this way. So it is better to go a bit sparse than dense if it is affecting your readability.
Readability counts.
Well, of course, readability counts, and it depends upon a lot of factors which we discussed in the last few lines. And let me give you one more, which is giving proper variable names. So consider this first block of code in which you have just written sn equal to some list, and then for n in sn print n. So we are not getting the context in which this code is being used. Whereas if you come to the block number 2, it is doing the same thing as the upper one, but the variable names are quite proper and giving you the context in which this code might be getting used. So in this way, the readability of the block number 2 is much better as compared to the block number 1. So as a programmer, one should try to follow all the good practices which are required to make a code more readable.
Special cases aren't special enough to break the rules, although practicality beats purity.
Okay, so let me explain this with a very simple example. Consider that you want to subtract 0.9 from 1.1. So what do you expect to get? Do you expect to get 0.2? Well, actually, we will not get exactly 0.2. We will get the answer up to a certain level of precision. So in Python, the floating point numbers, when divided, subtracted, or multiplied, provide you the result up to a certain level of precision that is not exactly the value which you expect to get when you subtract two decimal numbers. So if you just show this particular expression to anybody who is new to programming or hasn't done any programming, they will expect this particular result to be true, right? But actually, this special case isn't special enough to break the rules. We are not gonna break the rules of the precision in the floating point numbers just to set this particular statement as true. This is gonna be false because 0.2 is actually a very accurate value with up to only single decimal level of precision, whereas here the level of precision is quite different. So special cases aren't special enough to break the rules, and if you really want to get the desired behavior, then you have to be you need to be a bit practical about it. And here you can use the round function like this and you get the desired result.
Errors should never pass silently, unless explicitly silenced.
You should not try to get away through any error without properly handling it. Let's consider an example. Let's say you've got two variables a and b in your program, and at some stage of your program you want to divide them with each other and you get the result as c. So what you did is that you just put a try except statement here and then just run your code. So the code will run smooth, but the user who is running it through the console will never be able to know that they had tried to divide some value by 0, which is wrong. The user should be aware of anything which is happening in your code which is not normal. So for example, a better way to deal with this situation is to just do something like this. You specify the type of error which you are expecting, and for that what message should be printed for the user. So this is a much better way of handling it. So this means that errors should never pass silently. Okay, now let me give you another example where you can explicitly silence your errors. For example, consider that you've got a code in which you've got a dictionary and you ask the user for a particular key and you just print the value for that particular key in the dictionary. And if that key doesn't exist in your dictionary, then you will be getting a key error. And how you are handling that? You are handling that by putting that key in your dictionary and setting its value as 0 and then printing the value for that particular key. So this is a much better way of handling. So here you can get through without passing VR or without printing any error message because you are properly handling it.
In the face of ambiguity, refuse the temptation to guess.
if you're kinda unsure about something in your code, then you better not guess. It's better to remove the ambiguity which is leading to that kind of confusion. So let's say you have got a equal to true and b equal to false, and you have to check a condition in which not of a and B are checked if they are true or not, and if that is the thing, only then you are printing yo. Okay, but now there might be a case, let's say you forgot like what is the order of resolving this expression. It might be this, right? Or it might be something like this. So there can be multiple ways of solving this expression if you do not know the order of preference in which not and or are resolved. So if that is the case, then you can simply resolve this particular expression by doing something like this. If B and not A. So in this way, the not thing is resolved and it is not possible to have not of A and B as a whole. Or you can just put this kind of parentheses. So all in all, it's better to remove the ambiguity rather than just guessing.
There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch.
Okay, so let's take example of iteration in order to support this fact. Let's say I've got a list of sequences. I have got a range object, I have got a tuple object, I have got a list object, and also I've got a dictionary object. And for me, all these are sequences. And if I just want to iterate over them, I do not need to write a different kind of code for a different type of sequence. So I just do for each sequence in my sequences list. For item in sequence, I am just going to pass it, or let's say I just print the item. So I get all of them without any error. So it simply means that all kind of sequences will be iterated in the same manner. You do not need to write different code for different thing, and which supports the fact that there should be one and preferably only one obvious way to do it. In this case, iteration. And last line is actually a kind of a joke, like it might not be obvious to you at first unless you are this great Dutch person.
Now is better than never, although never is often better than right now.
Okay, so these two are quite philosophical lines and they are related to software development. So let's take the first one, which is now is better than never. It simply means that it is better to provide something now that works rather than working on it for a long time until you just run out of steam and find that that particular thing is now not required, or nobody has the enthusiasm to work on it now. So in that case, it is better that if you have got a product, and even if the functionality is basic or the code is not yet perfect, even though you can just try to bring that thing into the market and just see what the response is over that particular product. Another thing is, although never is often better than right now. So you should always implement the things when you introspect that you actually need it, and just forcing that you might need them should not be the only criteria, like why should you develop a software, because it often happens that people find that they kept on working on a particular software for a long time, and finally when they did that they found that it has got no place in the market and they had just been wasting their efforts. So these kind of things should be kept in mind while developing a software.
If the implementation is hard to explain, it is a bad idea. If the implementation is easy to explain, it may be a good idea.
Okay, so here is another philosophy which stems from a very nice quote given by Albert Einstein, which is, if you can't explain it simply, you do not understand it well enough. So it is basically related to the idea that we got in the second line of our poem, which is simple is better than complex. So if the implementation is simple, it is easier to be explained, then only in that case you will be able to maintain your code in the future, because if it is hard to explain, then you will be yourself be always puzzled and confused about your code. So that is a very bad idea, and it is a good idea to have a very simple implementation which could be understood by even the noobs.
Namespaces are one honking great idea. Let's do more of those.
Okay, so namespaces have been given a special mention in this poem, and that too in the last line, so that people could understand their significance and how do they work. So let's take an example to understand this finally. Like you got this cat equal to my cat in the global scope, and when you call the function yo, then you are just setting cat equal to my local cat. But now one needs to understand that this is the local scope, and any variable defined in this local scope will be vanished as soon as you come back to the global scope. So when you try to print cat here, it will be my cat only, not my local cat. So this concept of namespaces is very nice as it helps you to use a certain variable name again and again in different kind of functions. So it is allowing you to use the same name cat in your function even though you have used it already in some other scope. So that's why namespaces are one honking great idea, and let's try or let's do more of those. So finally, this brings us to the last line of our poem, which is line number 20. And actually, line number 20 has been left blank by Tim Peters, and it's up to you what you want to imply from it. So from my side, it will be keep yourself updated, keep searching for something new. So guys, that's it. It was a long poem, and if you enjoyed decoding it along with me, then do like and share this video. Also, don't forget to subscribe to my channel, Indian Pythonista. So that's it from this video. Thanks for watching.